This is a very quick walkthrough of exam solutions. For the first set, number 1, you're asked to find the equation of the line below, and you want it to be in y equals mx plus b form. And so the first thing we know we need to do is we need to somehow get slope and a point. And they're telling us the line is perpendicular to this line, and they give us a point. So let's get the slope from here, which is a hint of slope, and then use that and this point to actually get our line. And so we take this 8x minus 4y equals 2, solve it for y, and so for 8x was subtracted to the right hand side, divide by the coefficient of y, and you get this. So what this is giving you, though, is that the slope is 2 of this line. So here the slope is 2, but what we want is the perpendicular slope, which is going to be negative 1 over 2, the opposite reciprocal of the slope of that line. So you take the 2, flip it, get 1/2, change the sign. Then you use that negative 1/2 here to find the b. So it's y equals mx plus b. Here's the y from this point, the 1 from this point, the slope we just found. Solve that for b. Once you have that, now you're going to write your actual line. Here is the slope. Remember, not the slope of this line. It's perpendicular to that. So negative 1/2, and then the b that we found. For the next set of questions, part 2, we have 3 different parts. First, we have to solve by any method. When we look at this, we need to have all of the values and terms that you have on one side. And so we need to subtract to 15, and we need to expand the left side. So here it is expanded with the 15 moved over, still equal to 0. First go-to strategy you want to use is always factoring. And so we're going to factor this thing. When you look at 15, 15 has factors of 1 and 15, 3 and 5, and that's it. So which of those factor pairs have a difference of 2? This negative sign says each factor has a different sign. This one says the difference of those 2 factors is 2. So we're going to use 3 and 5. We put those in here, and then we check, put our signs in, verify that what you have is right. Plus 5x minus 3x is positive 2x, minus 15, and of course x squared for the first. And then we take each factor and set it equal to 0 by the 0 property, and then solve each one for x. So we get negative 5 and 3, which we put down here on the solution line. For the next question, part B, we can see that both sides are square values. So this is x minus 4 squared. 25 can be 5 or negative 5 squared. So let's take the square root of both sides. When you do that, you take plus or minus on the one side. So we get x minus 4 plus or minus 5. Now we have to solve for x, so we add 4 to both sides. And what you get looks a little weird. Here the student already has it subtracted out, but before you actually separate it, it looks like this. And what that's saying, 4 plus or minus 5. So 5 plus 4, negative 5 plus 4, get each of those values, and then you're done. The last one on the right, we can't take the square root like we did in the middle, so let's go ahead and get it equal to 0 by subtracting 3 from both sides. When you do that and you try to factor, and you can go through lots of machinations to try to get this thing to factor, it does not factor. And so what you have to do is use the quadratic formula. One of the most common errors on this problem was here, and making this the square root of 1 instead of the square root of 49 by adding those two together. So the negative signs were lost in the process. The last question on that page, we have up-down vertex. So this guy is opening up because the leading coefficient is a positive 1. The vertex is negative b over 2a. Go ahead and find that for the x coordinate, and then substitute that 2 back into the original function to get the y coordinate of the vertex, and then you get 2, negative 4. Axis of symmetry is the line that splits your parabola in half. It's always a vertical line for our parabolas that are functions, and so we get x equals 2. What's the y-intercept? Always set x equal to 0. When you do that in the original function, you get 0, so you get 0, 0. So now the question becomes, where does this thing hit the axis? And the way to decide that is to set y equal to 0 and then solve it. So take your function, set it equal to 0. When you do that, this is missing an equals 0 here. When you do that, take each factor and then you get 2 points. And so at this point, you can graph your parabola. You know the vertex, you know the 2 roots, you know it's facing up. So then you just connect those points. And now we need to write domain as all real numbers, because this goes forever to the left and forever to the right. All the x values here on the x-axis are covered, so it's all real numbers. The range or the y values covered are from here up, so you can write, remember your arrow over here looking at range. It goes from -4 all the way to infinity. That's what this is saying. It is increasing on the right side of the vertex, so from 2 to infinity. It is decreasing on the left side of the vertex, coming down like this, from -infinity to 2. On the next page for the application question, this student made a common error what others had done, and that was incorrectly taking this value, which is 4,000, and so they did correct their own error and put that here. But this picture is of 2 identical side-by-side pens. That means they're connected together, and you get this shared wall. So you get a width and then a length and a length. So when you set up for the so-called perimeter that also includes that shared middle fence, you get L plus L is 2L, and then W, W, W to get 3W. So the equation should be this, and then this area equation. Take the perimeter with this shared fence inside, and solve that for L. That's what's being done here. And then after you solve it for L, you're going to substitute that into the area function for L to get a quadratic. This quadratic is facing down because it's -3/2. That means we're going to have a parabola that looks like this. And at the very top, we're going to have a maximum. We're trying to maximize the area, so the x value of that parabola, or here it would be W, because we solved this for W's, that would be the value of this length of fence. So you go ahead and use -b/2a, and you get this. From that, then you substitute back into your perimeter, which has also the shared fence, and you get 1,000. For a piecewise function, you did not have to graph it, but this question was much easier if you did graph it. And so let's first look at evaluation. You take a -2. Which one of these 2 functions are you going to use? -2 falls in this interval, so we use x squared. -2 squared is 4. Be careful of this notation. This is really x squared. For the next one, f of 1, 1 does not fall in this interval because it's less than 1, and 1 does not fall here, so there is no function for us to use when x is 1. So that means there does not exist a point on this graph where x is 1, so you just say doesn't exist. When x is 2, we come up here to this again. 2 doesn't fall in this interval, it falls in this interval, so we're going to use this line. 2 minus 2 is 0. This is the equation they're using, so 2 minus 2 is 0. What is the domain? The domain, we piece together all of the values here. Yeah, it's a good idea to go ahead and draw a number line and then pull the values off of there. So for the top one, -2 to 1, include -2, don't include 1. 2 to 3, including the endpoints. Now, how do you write this in intervals? You use bracket, -2, comma, parentheses around the 1 for the endpoint, U for union to glue them together, and then 2 to 3 with brackets around it. Go ahead and graph this piecewise function. Remember, we are chopping up this interval and graphing it only in pieces. So the left-hand one from -2 to 1, from -2 to 1, we're going to graph y equals x squared. That is a parabola, has a solid circle on the left because we are including -2 in our interval, and then it looks like a parabola, open circle on the other side. You can pick points here to make sure you get them correct. The next interval, 2 to 3, including the endpoints. And so from 2 to 3, here we are. Sorry, go up here, 2 to 3. It's a line 2 minus x. So you need two x values. Pick the endpoints, because those are the points you're going to connect to get the y values, and then just connect them. We do that because now we can do the range. Again, use your little bracketed arrow over here. This one is -1. So we get to include -1 in this interval. And then we include all the y values continuing up until here we hit 4. And this should have a circle on the end. Now remember, this is all just scratch work, but it's going to help you write this range. So we are going from -1 all the way to 4, and we are including both endpoints. Now what some students get confused about is, what about this open hole here? Do we just go -1 to 1, then open parentheses up to 4? And the answer is no, because this guy here has a y value of 1, so 1 is still covered. And so the range is -1 to 4. For the next one, we are looking for revenue and going to find this revenue function. So let's take revenue is price times quantity. Price is given to us. Quantity is how many. So the quantity x. So we just multiply them together to get the revenue function. Now what is the revenue if 200 units are sold? So you find R of 200, put the 200 in for each of the variable slots, and simplify. So it is a dollar amount because it is a revenue. For the next one, what is the revenue if the price paid is 200? So we take this price function and put 200 in, and so 200 is equal to the price function. Subtract 2, add 2x to both sides, subtract 200, you get 200 equals 2x equals 800, divide by 2, and you get 400. Now you know the number of units you want. We want to find the revenue, so take that 400 and substitute it into the revenue function. You are rewriting your revenue function just so that you have it in easy reach for this next question. Algebraically find the quantity that maximizes the revenue. That's going to happen at the vertex. This is a parabola that faces down because of the -2. So the parabola goes like this. We've got a max. It happens at the vertex. Let's go find the vertex. The x-coordinate of the vertex is all we need. So -b is -1000 over 2 times -2, and you get 250. So what's the maximum revenue? This is really finding the y-coordinate of the vertex for the revenue function. We already know the 250 is the x-coordinate, so take the 250 and put it in for revenue, substitute it in for each of the x's, and just simplify to get 125. And what price should the company charge to maximize revenue? And for this one, to maximize that revenue for an x value of 250, you are going to substitute 250 into the price function. So let's go look at the price function, -2x plus 1000. Sorry, now we'll go down here. And you should charge $500. Hoping this all makes sense. If you have any questions, just come and see me. Hope you're having a great day.